Hi friends, welcome to the last video in the parsing series of LangChain, and in this video we will cover modern structured generation schema provided by the LangChain, which is called with structured output. So with using this with structured output, we can bind the LLM directly to a response schema. So all the examples that you have seen above, you were creating a parser, you were parsing this parser as a chain or as a post-processing step, but the LLM was returning the response based on the instructions given by the parser in the prompt. So basically whatever the prompt was saying, LLM was following that. But using this with a structured output, you can directly bind your LLM to the response schema that you want in the answer. So instead of manually writing parsers or manually injecting format instructions or JSON, you directly bind a schema to a model, and model then generates structured outputs natively. So let's see the example real quick. So I have created an incident class, a Pydantic object class, and I am like here I am passing a severity, service, and a cost, and I am passing the description for all these fields. Now, as you can see, instead of using any parser that we have seen above in our web examples or a custom parser, I am directly using with the structured output function of the LangChain, and I am binding my LLM to return the output in this particular format. So here what I am saying, LLM dot with the structured output and then incident. So here I am saying to the LLM that whenever you return the output in this particular format only. So now I will get a new object of the LLM which I am naming as structured LLM, and after that when I am creating my prompt with the incident text or with the very input that I want to pass to the LLM, the incident that I want to analyze, I want LLM to analyze, I am passing that while invoking this particular chain which contains just the prompt and my new LLM, structured LLM, that is binded to the this incident class. Now as you can see, I'm not passing any format instructions here, like as we have seen in the other basic parsers. Like we were passing format instructions, we were passing even with the custom parser, we were passing instructions to the LLM to how to return the output in this particular JSON and things like that. We don't need to do anything in this case. We are just telling LLM to analyze this particular incident and return as the output. We don't have any instructions in our prompt, and how to return the output. We are not providing any instructions like that to our LLM because we have binded our LLM to this particular output format. Now after this the chain is invoked, if you will see the result, you can see the result is coming as an incident class and in the same format as we were expecting, because of this function call, LLM is now bound to return the response in this particular format. Let's see another a bit more complicated example like this. So we have a schema, we have a JSON here where we have title, incident, schema, description, then the type. This is a schema, right? We are saying that we have a incident schema here. This is the description and it's an object. It has these properties, which is severity, service, cost, which is again type, description, the type and description of the each field. So here we are using a schema instead of a Pydantic object. Please note that this is exactly same that we have seen above in the example. This is just by using a Pydantic object, and this is just in the format of a schema. We can also pass this schema inside a with structured output like this in a similar manner, and the LLM is bound to follow the rules that are written inside this schema and return you the output in the similar manner. So again I am passing the exact same prompt with the exact same incident text, and I am calling the chain as we have seen in the example. So as you can see, the output written by in these two cases are exactly same. Here severity is high, checkout service, and database connections, pool exhaustions. Same thing here. Severity is high, checkout service, and database connection, pool exhaustion. The only difference is here you were getting an incident class object, a Pydantic object, but here as you were passing a schema, you are getting a dictionary. So because of the input that you are passing, that you are binding your LLM to, the type of the response may differ, but it's bound to return you the response in the exact same format. Now let's see some advantages and disadvantages of using this with a structured output. So first let's compare it with the other traditional parsers. So native structured generation like this, prompt LLM parser. So LLM first generates the raw text in this case, then the parser tries to convert the text into the structured data. But with this kind of approach, the model directly generates structured data using tool calling, function calling, JSON mode, or schema-aware generation, and it's more reliable than that. Then you don't have to pass any manual format instructions that we have seen in the parser as well as the custom parser in the web examples. You just tell LLM what it needs to do, and it takes the format instructions from that schema or the Pydantic object class. So this is more reliable, and the JSON is less malformed as compared to the other scenarios. It also supports schema validation. So as you can see in the first example, we were passing a Pydantic object, right? So we are expecting a string here. So it also supports schema validation, the type validations that were supported by Pydantic output parser. The code is much cleaner. So instead of doing things like that, you can just do this and invoke the LLM. So better nested schema support. You can nest the objects as well. Like you can, here the action item is a list of another class called action item. You can do that as well. Better production reliability. It's more stable, more predictable, and more production safe. So again, it's better than regex parser because, as you know, regex parser is very fragile, which is not the case of this parser. With the structured, which is not the case with the structured output function, as it type checks the value as well. It's better than JSON output parser because of the type checking. Because JSON output parser relies on prompt engineering, like it parses the generated text and it will fail on malformed JSON. But with the structured output function, it will use native schema-aware generation, reduces malformed outputs, and avoids most JSON parsing issues. So it's more reliable than the JSON output parser. It's also better than Pydantic output parser because it also takes care of type validations. Like you can pass this whole Pydantic object inside it, and it takes care of all the types validations as well. So and provides much more cleaner code. So Pydantic output parser still follows generate text, parser text, and validate schema. With the structured output, shifts structure and formats into the generation process itself. So here, after the text is generated by the LLM, parser comes into picture after that. But here, while the generation step only, the format of the output is decided. So this reduces parser complexity, formatting errors, and the validation failures. Now let's look into some limitations. It requires some model support. So it may not be usable by all the other different types of models. Like there could be models in the market which are not still supporting this with the structured output format. So it provides behavior differences. Like behavior may differ with the model depending on the model you are using. So it may behave differently with OpenAI or Anthropic models or Gemini models or other models. So depending on the model that you are using inside your in your agent, the behavior of this approach may differ. Again, it's not a replacement of the business logic. For example, again, you want to add some business logics as we have seen in the custom parsers. You cannot do it with that. You have to create your own custom parsing layers on that again. Then less fine-grained recovery control. Obviously, as you can see, the other parsers which are out Pydantic parser, JSON parser, they can be combined with output fixing parser and retry parser, right? To retry the output or fix the output, right? This will not be possible with this approach. So it also limits schema complexity, nesting depth, and behave inconsistently with large schemas. It may behave weirdly with the large schemas. It can still fail because possible issues could be incomplete objects, hallucinated fields, enum mismatches, things like that. So for example, if the LLM generates the wrong output, it will still fail. So modern enterprise summary is like modern AI systems that use with a structured output, they behave like this. They bind the LLM with a structured output using a Pydantic object. Then they add Pydantic validations and custom validation logic on top of that to verify the response. So best one-line summary is, with a structured output, move structured generation from parser level to the text processing to model level schema aware generation. So the only advantage that it provided by this is that it makes your code cleaner. It takes some complexity away of passing the instructions in your prompt to generate a specific output, and it moves the structured generation moves the generation of the particular response from the parser level to the next generation level. So after that, you can add your own logic and you can just verify it using other parsers, Pydantic validations, or you can write your own custom business logic to verify the output and before pushing it to the before returning the response to the user. And this is how generally used in the production flows. So this is all about this video. Please share any doubts or any questions that you have in the comments. I will try to answer them possible. And please like, share and subscribe, and we'll see you in the next video.